Hi, Mrs. Jacobs here, physics teacher at Naperville North High School, and I'm here to do a tutorial on how to draw an acceleration versus time graph. The most important thing is to know the definition of acceleration. Acceleration is the slope of the velocity versus time graph. Okay. And let me explain why that is. When I have a velocity versus time graph, velocity is usually in meters per second and time is in seconds. So if I do the slope of a graph of a velocity graph, which is rise over run, the rise unit on the y-axis is meters per second, and the run unit on the x-axis is seconds. So whatever slope I get, let's say I have this, and the slope is +2. That's +2 meters per second. Okay. And what that means is that for every 1 second of time, the object is getting 2 meters per second faster. Another way to say that is it's getting 2 meters per second faster every second. Okay, so this would be starting fast. Let's say it starts at 1 meter per second. And then every second, it's covering more and more position because it's getting faster and faster. And every second, it would gain. I can't even draw how long this velocity arrow would be. But every second, it's gaining 2 meters per second of velocity or speed. Okay. And that's the slope. The keyword is slope. I'm going to be using the graphs that we drew in the last video tutorial. So if you haven't watched how to draw a velocity graph, how to interpret a velocity graph, you might want to look at that. But if you haven't, you can also just kind of look at what's going on here. So this was a velocity graph that was given, and then I drew the position graph that matches. One important thing about acceleration is it's not influenced by which way the object is moving. Not dependent on which way the object is moving. Okay. It's only dependent on the slope of this velocity graph. Okay. So let me add a third graph to each of these problems. Okay. I basically ignore the position graph and I just focus on the velocity graph. And I say, what is this slope? This line has a negative slope. So the acceleration is negative. It's below the x-axis, but it's constant. It's a constant negative slope. This line has a positive slope. So the acceleration is positive. Okay. This is a situation where it doesn't match which way the object is moving. This object had velocities below 0. And you can see from the position graph, it's moving in the negative direction. But that doesn't mean that it has negative acceleration. It has positive acceleration. Okay. The other thing I should say up here for this one is this object was speeding up. Speeding up doesn't mean positive acceleration. It could be negative. In this case, it's negative. Okay. The reason why it's speeding up is because the acceleration and the velocity are in the same direction. Okay. We're gonna really hit on later at the end of this unit that acceleration is tied to force. Okay, so acceleration is not based on which direction it's moving, it's about which direction the unbalanced force is acting. What I would focus on is I just need to know this slope, whether it's positive or negative. This slope, this is important. This object's turning around, slowing down and speeding up. But look at the slope of this line. The slope of this line is negative the whole time. Okay, so there were different stories for position. There were two different stories of motion for velocity. There's only one story for acceleration. It has a negative acceleration the whole time because the slope is negative the whole time. Ah, this one. Glad we have one where if we have constant velocity, draw the acceleration graph for this. When I have a flat line on the velocity graph, the slope of a flat line is 0. Okay, I don't have acceleration when I have constant velocity. So this is going to have two different accelerations. The first acceleration is on the x-axis, it's 0. The second acceleration is based on the slope of this line, and that is a negative slope. Okay. Hopefully that was helpful. You just focus on what's the slope of the velocity graph.